Okay, so this one's kind of short and sweet. We're going to talk about powers of 10. And whenever we raise anything to the 0 power. So powers of 10, I'm not sure if you guys did this, but you don't have to write this down. If I asked you what this was, would you be able to tell me without using a calculator? $10,000. How'd you do that? Okay, so 10 times 10 times 10 times 10 equals 10,000. That's right. How about that one? 1,000, because it's 10 times 10 times 10. But without doing all those tens, can you find a quick way to do it, Finley?
I was just looking at it, I don't know if it's right for you, but it's 10 times 10 to like 10 to the power of 4, it's just 4 zeros.
Exactly. That's a shortcut for powers of 10. So if I said 10 to the 10, you would just simply write 1 and then 10 zeros. And that would be your answer. Okay? So that's a shortcut for finding powers of 10 without 1. So let's just look at a few. So if I said 10 to the 9, 9 zeros. Anybody know what that number is in words? Lucy?
Is it 1 million?
1 billion. We get 10 to the 8. It's a 1 and 8 zeros. How about that? 100 million. We have 10, 7 zeros. 10 to the 7. 10 million. And you guys can see the pattern. So clearly you guys are familiar with this. We did 10 and to the 6th, or 1 and 6 zeros. We get 1 million. And then once we go lower than that, we're going to go into the thousands. So the 100,000, 10,000, 1,000. So 10 to the 5th is a 1 and 5 zeros, which we did. Or sorry, 10 to the 5th is a 1, 5 zeros. I think right. There we go. And that's 100,000. And 10 to the 4th, we did. So it's 4 zeros for 10,000. And to the 3rd, we did 1 and 3 zeros, 1,000. And to the 2nd, or 10 squared, 100. Then 10 to the 1st, anything to the 1st is just itself, or the 1 and 1 0 is plain old 10. So that's pretty straightforward. So that's powers of 10. What about the zero exponent? Well, here's how we can find anything raised to the zero. So like from above, I'm just going to start writing some powers. 10 to the fourth, 1 and 4 zeros. 10 to the third, 1 and 3 zeros. 10 squared, 1 and 2 zeros, and 10 to the first, 1 and 1 zero. What's happening in this column all the time? What am I doing? What's happening? Is the base changing? Is the exponent changing? If so, how's the exponent changing?
The exponent is between by 1.
Right, so we're subtracting exponent minus 1, minus 1, minus 1. So if we did the next one in the pattern, we get 10 to the what? 0. What's happening to the numbers here? Yeah, it's 1 less 0 every time. Or another way to say that, we're dividing 10 every time. Dividing 10 means to take away a 0. So therefore, what would this be? Well, it'd be 10 divided 10. It's just 1. Anything to the 0 power is always 1. I know it seems a little weird, but that's how we get it. Like if we show a pattern, we can see how we get that. So just to wrap up with a couple of questions. We've got a shopping mall in Singapore that has approximately 1 million square feet of retail space. Imagine that would be equivalent to almost 3 IKEAs together. So it's pretty big. Because IKEAs are usually around 400,000 square feet. How do I write that using the power of 10? A million. 10 to the power of 6. So we did all the way up to a billion. How would you do a trillion? 10 to the power of 10? If we went 10 to the power of 10, wouldn't we get 10 billion? And then 10 to the power of 11 would be 100 billion. And then the next would be a trillion, which would be 10 to the power of 12. 10 to the power of 12. And if we wanted to go up to the next word, we'd have to add 3 exponents, exponents, 3 to the exponents. But we won't worry about doing that. And then finally, a little practice with the 0 exponents. Remember, and we're going to throw some negatives in, we're going to throw some parentheses in. So remember what we talked about yesterday, parentheses matter and so do negatives matter. But first of all, what's 4 to the 0? 1. What's negative 4 to the 0? No parentheses. Finley? Negative 1. But what if there's parentheses around the negative 4? Positive 1. Good. Excellent. Okay. Like I said,